All right, it's done. Let's share the screen. Wait a minute, this is working. Leave, join, don't connect audio. Right there. Now we're ready to rock. Start the broadcast.
Today, extra cash has been my absolute lifesaver because it gives me
Optimize and let me open this quickly. Let's go right here. Say as a participant, sign in. All right, thank you. Go away, please. Here. Okay. All right, let's see. This is countdown number 1. This is our 2 p.m. I think we are right here. Let's get started. And let's see. Give me a random number between 1 and 25. Right there. Okay. All right. So before we launch into
Sportsmaster was spotted coming through Louis Armstrong New Orleans International.
all of this, let me see. Doing well. Okay.
Street clothes.
Okay. Let me see. Okay. I hope everyone is doing well. Let me see. So, today we like to do a homework session. Again, now with my earlier group, we did a homework session, but there weren't that many like multiple choice. So I don't want to be like you're off the hook, but you might be off the hook as far as multiple choice. It just depends. We made it through, I don't know, however many questions we made it through. But if we start to get a decent amount of multiple choice, and if I do the polls, then I'm going to rely on that for attendance, right? So if I do the poll to audience and, I need to know that you're at least paying attention, that you're conscious on some level. And again, you only get credit if you get those right. That's if they appear. If they don't appear, then you're off the hook, okay? Let's see. Yeah, so today we're going to be doing a homework session. We're in like the home stretch. There's not much left at all. Let me see if I can pull up a quick. You guys keep on muting yourselves. You have questions? Let's see. Okay. So we glance at a quick calendar. Let me see. Oh man. All right. So I have to mention this. Like, we just got our next president, right? Apparently, I think I'm under the impression that Trump won, right? So, I wasn't really convinced about either candidate. I felt like with Trump, there are things that you can argue that would be much better off. Because I felt like people were going to challenge Kamala. Like they weren't going to take her serious. And like they were just going to push up on her just because she's a female. So that was one thing. Like, and then it's like, I couldn't read Kamala, and I was just like, I don't know. I wasn't really feeling the hype. With Trump, we kind of have a sense of what we're getting as far as the pros and the cons. I feel like on some level, you do have to acknowledge the resilience of Trump. To be all those like, going all this stuff thrown at him, and he still survived. One person I was listening to was like, if that stuff were true, then they would have thrown him in jail a long time ago. Not to say that he's like, spick and span clean, but like the serious allegations, I don't know, for whatever reason, they didn't stick. So I thought that was interesting. So that actually makes me feel a little bit better. Now, obviously, he has his own set of challenges, like with his bolstering of the police. Like, people of color, we don't really need more of that. We need like sensible, reasonable stuff. But, so if I had to choose the lesser of two evils, you know what I mean? So again, and who knows what would happen with the other track. personally, I was indifferent. I could get a strong pro and a strong con for each candidate. So, it is what it is at this point. That's the long and short there. Okay, so let me see. So again, this week we're working on section 2.3. I want to say that exam 3 becomes available this Sunday morning at 11 a.m. And then for 7 days, you can earn up to 100%. So all next week is exam-related materials. Probably on next week on Monday, we'll review for exam 3. You can actually start your exam early. You can actually go ahead and start your exam. And then, like, if you have questions, you can screenshot them or write it down, and we can actually work on it together during class. Like, you can ask questions about your exam. If you feel confident, then, as long as you get it submitted, just get your attendance credit, and you're Gucci. So that'll be Monday, and then Wednesday, more than likely, I'll do an attendance quiz, just because, to give everybody a chance at a breather. Something between 5 to 10 questions, unlimited attempts. You can only access it during our class time. So that'll probably be Wednesday of next week. And then I think we have, let me see, we have 2 more sections. So on the 18th, November 18th, that week, we'll do section 3.1. Monday's the lecture, Wednesday's the homework. And then that week of Thanksgiving, the 25th, we're going to meet on that Monday, and that will be the last of the new material. I think it's going to be section 6.4, system of linear equations, right? So that Monday, the week of Thanksgiving, we're going to meet. Obviously, we're not going to meet on that Wednesday. I think the school closes at noon on Wednesday of Thanksgiving. So we'll meet that Monday. We'll be out pretty much for the rest of that week. And then we come back, and then we meet that Monday and Tuesday. So that Tuesday, December 4th, is the last day of class. So that Monday the 2nd and that Wednesday the 4th, we're going to use those as review days. So that Monday, we will review the first half of the semester. So everything just the first half of the semester. So I guess anything pertaining to exams 1 and 2. Let me think. Or we could... Let me think. Give me just a moment. I still feel like because we could squeeze an extra day in there on that Wednesday, November 20th. Instead of doing a homework session, just go ahead and do the section 6.4, that last section, and we can be done with the new material on November 20th. Then that will give us 3 days for review. And what we could do then is take each day, we'll review each exam, right? So on November 25th, we can review exam 1. December 2nd, we can review exam 2, and then December 4th, we can review exam 3 and those last two sections. And I'm leaning more towards that structure. I feel better about that. It spaces things out a little bit more. I think more than likely that's what I'll do. So we'll know by November 20th. If November 20th, if I'm doing the last section, then that's how okay, we should have 3 days of review, yada, yada, yada. Okay, and then one other thing is our final exam. More than likely, I will host your final exam. So usually for College Algebra 1, there's a departmental final. But with this being remote, I think what we've done for the past few semesters, the department chair was like, well, Pfeiffer, you've been doing this long enough, you can, create your own final, right? So if I create the final for you all, then it'll be pretty much like exams 1, 2, and 3, just cumulative. So everything from the beginning to the end. If the last day of class is December 4th and I'm making your final, then I'll make it available on that Sunday, December 8th, and it'll be due that Friday, December 13th at 11:59 p.m. For those 5.5 days, you'll get unlimited attempts. The system is set to take your highest score. The hard deadline for all assignments is that Friday, December 13th, because shortly thereafter, we have to calculate final grades. Okay. So leading up to that week of finals, which is that second full week of December, my recommendation is to finalize all your assignments you have access to Pearson. Keep in mind that with our assignments in Pearson, we get unlimited attempts. The system is set to take our highest score. And there is a 5%, I think it's actually a 10% late penalty. If I can just remember going forward, I will change those. I don't mind those being 5%, but I think that's remnants of an older system I had in place. But I think it's set to 10% late penalty. At one point, one student asked about extra credit opportunities. More than likely what I'll do for extra credit, if I can, that means that it's not skewing the grades too much. What I do for some of my students is like I take the overall my math lab score and I scale that as an additional 10% of the overall grade. So potentially you can earn up to 110% out of 100%, coupled with unlimited attempts and the system is set to take your highest score. I think that's enough, right? And it's not really proctored, so you can ask for help on old assignments, right? You can get help. You can work together and collaborate. You can sit down with tutors or myself, and go line by line. It's okay. On your end, I just need you all to I need each person to submit their own work and yada yada stuff like that. Okay, if there are any questions, feel free to unmute yourself or type in the chat to get my attention and we can talk about it. That was a pretty good rundown though. It's like I feel like I need to use that for my other groups. Anyway, okay, let me think. Yeah, so let's jump into today's material. So we're going to start with question 5. And we're working on section 2.3. So I'm going to minimize this. This layout is okay. Attendance, you don't have to like, only time let me see, is there anything we can do to make up attendance assignments? Don't stress too much about those. Okay, that's a good question. I don't want you worrying about those. Those are just for attendance. It only becomes an issue if you get like 4 or more unexcused absences. If you have 4 or more unexcused absences, then just kind of get my attention at the end of class. As long as you have intent to finish, you're submitting your assignments promptly, and you minimize unexcused absences going forward, it's okay. I just have to have something to see who's here, who's not here. I just need some signs of life. I do have some students that are like excessive unexcused absences, so those are the ones I need to like, okay, they kind of need to watch out, right? But as long as it's not excessive, don't worry about it. Don't worry about it. With the late penalty, I would like to change it to 5%, but it doesn't let me because you guys have already started. So I don't know that I can change it to 5%. But the 10% isn't bad either. Like I had some students that I usually don't like to talk. They wait till the last minute to do literally everything, and they got everything in, and they maximize the scores. So they got their 10%. They got their 90 on a lot of assignments, which is fine, So it's not going to hurt you. Like, it's actually going to be okay. Coupled with the potential extra credit opportunity, of the overall my math lab score. Last week I didn't know about the quiz. Yeah, just don't worry about it. Okay, another thing when it comes to those, so you can check your attendance in Blackboard. I tried to be a little lax because I know last week was unexpected, and I didn't really get a chance to give you guys a heads up. So as long as I saw any signs of life, essentially I gave you credit. As long as if you either tried to access the Zoom like normal, because I can see that, or if you completed the quiz, then I essentially gave you credit. I would mark you absent if I didn't see you try to log into the Zoom, or if you didn't do the quiz. Like if you didn't do anything, no signs of life, then that's what I mark you as absent. So again, you can check your attendance on Blackboard, and again, it's really only an issue if you have 4 or more unexcused absences. I think you're really allowed 2. 3 is like pushing it. 4 is like, okay, you're okay. Like now I'm like, okay, what's going on with this student, right? So I think 3 is really supposed to be on the 3rd one, but I think I'll probably do it on the 4th one. But yeah, as long as you show intent to finish, like you submit your assignments promptly, you minimize the unexcused absences, I'm not gonna let attendance stop you. Like if you really want to finish, I'm gonna make sure that you can finish. Okay, and if you're concerned, again, just check your attendance in Blackboard. If you have more than 4 unexcused absences, just kind of get my attention. Either use my office cell phone number or at the end of class, and we'll try to figure something out so that attendance isn't an issue. But again, going forward, just try to keep the unexcused absences to a minimum. These are great questions. Okay, guys? So that was a little play-by-play of what you can anticipate over the next coming weeks. After this section, I think we only got 2 two more sections of new content. The rest is going to be reviewed from that point forward. Attendance. So I want to say if you go to Blackboard and log into our course, on the left-hand panel, you're going to see something that says attendance, and that's where you can see. That's where I keep track of you all's attendance in Blackboard. Okay. All right. Let's see here. So this one says, let me see. I'm gonna zoom in just a little bit. 250. 250. Come on. It looks a little weird. No, I'm gonna have to zoom out. I'm not feeling that. 200. All right, that's reasonable. Use synthetic division to find P of K for the given value of K and the given function P. So K equals 3. They want us to find P of 3. So then this is an application of the remainder theorem, right? So we can do synthetic division where 3 goes into the chair, and then whatever our remainder is, that's going to be P of 3. Okay. All right. So this is a question on synthetic division. So let me start by getting a copy. Yeah. And at least with Trump is an anomaly. I feel a little bit better with Trump, to be honest. As far as I don't know. Like, again, you can argue either side. You know, it's all about what perspective you choose to kind of latch on. I don't think we would have been 100% since she was inarticulate, you know. All right. All right, so let's see what's going on here. Synthetic division. Okay, so if we're going to do synthetic division in this case, in the chair, in this case, will be a 3. Okay. Now, when we go to do synthetic division, the first question we ask ourselves, do we need any placeholders? All right, do we need any placeholders? And the answer is yes, because it skips over x to the power of 1, right? So we need a placeholder for the x to the power of 1. Okay. So then if we take our coefficients, there's the 1, the -2. Here's our placeholder right here. And then 4. Okay. It was a degree 3 polynomial. We should have four numbers or 4 terms, right? So since we only had 3, we were missing 1. So we got our placeholder. So now we're ready for synthetic division. Okay. When we go to do synthetic division, the first number just comes down. Okay. On a diagonal, we multiply. Vertically, we add. So then 3 times 1 is 3. 3 plus -2 is 1. 3, 3, 9, 13. Okay. So what we're saying is that if we were to plug 3 into the original, the answer would be 13. Okay. So we're just going to submit 13 here. Now we could check it, you know, we could check this in our calculator, but for the sake of time, I'm going to submit 13 here. Nice. Okay. Generates. Okay, that's fine. We can do the next question. Use synthetic division and the remainder theorem to find the indicated value. Okay, that's fine. We'll go ahead and do synthetic division. You know what? It might be a little bit faster. I guess I could still screenshot it. So let's go. Let me zoom out here. All right, that's decent. Okay, can't see anything here though. I guess that doesn't really matter so much. No, that doesn't. Well, all right, let me get a copy of this, even though it's not showing the label that I would like. What I could do is like this. And oops, like this. Uh, um, All right, let me see how I feel about this. We're gonna try this one. So I get a screenshot of this. I like it because at least it'll show like my question ID. So if you guys are using it, you know, as a reference, you know where it's coming from. Oh man. So yeah, my device has been like lagging all day, by the way. So you're just gonna have to bear with me. Okay. Right. We're gonna take that. We'll drop it right here. It's a little bit excessive. Okay. I don't know. I probably won't do it this way going forward. It just takes too much. I'll use it for this one. All right. I know it's a little bit small. I'm not feeling it. Here, I'll just rewrite it. Let me see. Use synthetic division and the remainder theorem. Okay, so we have this f of x equals x to the 4 plus 5x cubed plus 6x squared minus 4x minus 4, and we're asked to find f of 7. Okay. So I think this is a repeat of what we just did in the previous example. In this case, 7 is going to go in our chair. And then again, we ask ourselves, do we need a placeholder? We got power 4, 3, 2, 1, and then 0. All right. So we don't need a placeholder. So then we just take our coefficients. 1, 5, 6, -4, and -4. 1, 2, 3, 4, 5. Okay. So then synthetic division again, the first number just comes down. Diagonal, we multiply. Add 70 plus 14 is 84. What is that, a 90? 630, oh man, this is getting up there. 626. 626. Let me see, 636, 42, carry the 4, 14 and 4, 18, 36, 42, so 43. 4382. So 4378. That's our remainder. So our claim is that f of 7. Man, good chance I got this one wrong. These ridiculous numbers. Come on. All right. So we got 4378. 43. Come on. 78. All right. Woo-hoo. All right. So our numbers are good. All right, let's see. All right, we're going to let this ride. We're going to keep going. I'll create some space there. Let's go to generate. Let's go to question 22. Right there. That one should be 22. Okay. So here we're asked to find all rational zeros of f. Okay. And then use the depressed equation to find our roots. So basically, we want us to find our roots, all right? So this will be an application of the rational zero test. Yeah, the P over Q business, okay? So what I'll do, yeah, it's fine. All right, here is good. Like that, like that. Okay. So, I'm not too fond of this new format that Pearson has, just because it's a lot more challenging for me to get my reference. It is there, but I just don't like the layout. Like before, it flowed a little bit better. I don't see where I can, without changing my zoom and stuff. Anyway, it's fine. Okay. So P over Q, right? The rational zero test. So we're going to have our P over our Q, okay? So P are the factors of our constant term. So in this case, it's going to be 8. So the factors of 8 are, let me see, plus or minus 1 and 8. And then what, 2 and 4? So I think that's it as far as the factors of our constant term. Q comes the factors of our leading coefficient. We got lucky in this case because our leading coefficient is 1. So, there's no need to write it because the only factor there is 1. So then our list is already generated. So what we're saying is that if this polynomial has any rational zeros, it's going to be somewhere in this list, right? These are not the actual rational zeros, but again, if this polynomial has any rational zeros, it's going to be somewhere in this list. Okay. Let's see. So now we could just plug in 1, and we can do a guess and check. But what I like to do, I'm going to use my trusty dusty rusty calculator to go ahead and see, can we quickly find that first zero. Okay. So let me reload and refresh. Okay. So now in my equation editor, I'm going to go to y equals x cubed minus 14x minus 8. Okay. And I'm just going to look at the graph, see if any of these, if we have any of these x-intercepts. It looks like -1 is, wait a minute. Nope. It was close, but not necessarily on the money. 1, 2, 3, 4. Okay, 4 is a possibility. So again, I just used the graph and looked at my x-intercepts. I was like, oh, it looks like 4 is an x-intercept. So now on my paper, I'm going to do synthetic division to confirm or deny whether 4 is one of our zeros, right? So I just use the graph to quickly find that first zero. That's just for the sake of time. So whenever possible, if not, then you can do guess and check, and that's going to eat up some time, right? But if you can just look at the graph, right? So we looked at the graph, we got to claim that 4 was one of our potential zeros. So now we want the coefficients. The next question is, do we need any placeholders, right? Do we need any placeholders? We got 3, it skipped squared, so yeah, we need one for the square, right? We need a placeholder. So the first coefficient is here. For the power of 2 is a placeholder. And then power of 1, we get this -14, and the constant is -8. Okay, so now we're ready for synthetic division. Okay, again, the first number just comes down. Diagonal, we multiply, we add, we multiply, we add, we multiply, woohoo! And we have confirmed that it is indeed a 0, right? So now we have at least one 0. We started with the degree 3, so that means at this stage we're now at a degree 2 polynomial. Okay. And if we want to incorporate the 0 that we just found here, let's just rewrite it. So at this stage, we're saying that f of x right now is equal to, if 4 is our 0, the factor is going to take on the form x minus 4. And then we have this x squared plus 4x plus 2. Okay. So now we're trying to factor that down. I think if we try to factor it in traditional sense, like we can't find two numbers that multiply to give us 2 and add to give us 4. So then since that second one is a quadratic, we could either use a quadratic formula or we can do complete in the square. We can do complete in the square. I'll just do the quadratic formula. I was about to do complete in the square. I was like, no, let's just keep it simple, silly. Right? So quadratic formula, x equals, let me see. The negative boy couldn't decide to go to the radical house because he was square, so he missed out on 4 awesome chicks. And it was all over by 2 a.m. That's a quadratic formula, okay? So then from the above quadratic, our A is 1, our B is 4, and our C is 2, okay? So then if we plug those in, it's going to be -4 plus or minus the square root of 16 minus 4 times 1 times 2 all over 2a, or just 2. Okay. Let's see. -4 plus or minus 4 times 2 is 8. 16 minus 8 is 8. Square root of 8 is 2 root 2. All divided by 2. So then ultimately we get -2 plus or minus the square root of 2. Okay. So then all zeros that we get, if we put all of our results together, the first zero that we got was 4. And then we also got -2 plus or minus the square root of 2. Okay. So these are the roots that we were able to generate. Okay. And again, we could check this. If we plug each of these into the original, they should all generate 0. Actually, I think I do want to showcase this. I started to not showcase it, but I think I do want to showcase this. All right. So I think we already have the function in there. I'm just going to pull up the function. I want to evaluate this function when x is 4. We should get 0. Okay. We'll recall. Now we're going to evaluate when x is -2 minus the square root of 2. So -2 minus the square root of 2. Okay, I think that's good. Let me see. That's essentially 0. Let me check one other thing, see if this makes a difference. Yeah. So it's basically 1 times 10 to the -12. So it's practically 0, right? So that essentially counts as 0. And then we're also going to plug in plus square root of 2. And we're done. We'll get 0, right? So yeah, these all three of these are good. So then and we're here. This is not displaying properly. I'm gonna have to zoom out a little bit more. So we get 4 comma -2 plus or minus the square root of 2. Okay. Okay. Again, I would zoom in more, but it is kind of throwing a tantrum. Maybe if I do that and then this, I can zoom in a little bit more. Hopefully this works. So, okay. What's the time? All right, we got time. We got like 10, right at 10 minutes. Generate. I think we did 5 already. Let's see. We did. So we'll go ahead and do 7. Otherwise, let me see something. Yeah, I wasn't feeling it. What if I go like this? Let's just do this here. Okay. So this one asks us, use the factor theorem to determine whether the first polynomial is a factor of the second. Okay, so in order for the first polynomial to be a factor of the second, when we say that second polynomial divided by the first, we should get a remainder of 0, right? If we get a remainder other than 0, then it's not a factor. So basically, we're just going to do synthetic division. Okay. So first, I'm just pulling a copy. It sucks we don't have the question ID. I'm just not filling the layout. But it's okay. You at least know it comes from section 2.3. Okay, and we're just gonna go like this, I guess. Oh, that is broken rare. I guess we'll just kind of switch between that. That's gonna have to work for now. All right. Okay. So we want to do synthetic division with a potential 0. If x plus 6 is our factor, that means our potential 0 is going to be -6. So we need to put -6 in the chair. Okay. Do we need any placeholders? The powers go 3, 2, 1, 0, so we don't need any placeholders. If we take our coefficients, there's a 1, a 7, 4, and negative 12. Okay. Again, the first number just comes down. On a diagonal, we multiply, we add, we multiply, we add, we multiply, and indeed we get our remainder of 0. So then, because we got a remainder of 0, is it a factor? We would say yes. And check. Generate 12. Now, one thing I know that I could do, I just don't have the equipment. You know, I think if I had like a powerful device, then I could do like the whole OBS, like kind of how like what they do when they're streaming the gaming. I have one for like one device and another for other devices. But I'm doing all of this directly from like an iPad, so that's why it's kind of a little bit choppy. What do we say? 12. Okay. Let's see. So 12, right there. I mean, it does show everything I need. Find K such that
I'm cooking.
Somebody's going through it. Find K such that f of x has this as a factor. Okay, so we got that K in there. Okay. We don't need that. I'm gonna get rid of that. So I'll just take this. Okay, so this one's a little bit interesting. This is gonna be the last one because we're pretty much out of time. We'll take a copy and we'll drop it right here. Okay. So if we want x minus 5 to be a factor, that means when we put 5 in the chair and we do synthetic division, we need the remainder to be 0. So even though we don't have all the coefficients, let's proceed following that train of thought, right? So again, in order for x minus 5 to be a factor, 5 needs to go in the chair, okay? We don't need any placeholders. Every power is accounted for. So now we take our coefficients. The first coefficient is 1. Next one is negative k. Just go with it. The next one is k. Again, we're just going with it. And the final one is 35, okay? So then if we do synthetic division based on what we have, if we bring the first guy down, on a diagonal, we multiply, so we'll get 5. Vertically, we add, so we'll get 5 minus k. Diagonal, we multiply. That's going to be 25 minus 5k. Vertically, we add. That's going to be 25 minus 4k. Diagonal, we multiply. That's going to be 125 minus 20k, okay? And then vertically, we add 160. So 160 minus 20k, okay? So now, again, we want to find a k such that x minus 5 is a factor. If x minus 5 is a factor, that means the remainder needs to equal 0, right? So now that we've got an expression for our remainder, we need this remainder, which is this guy. We need this to equal 0, okay? So if we add 20 to both sides, divide both sides by 20, 16 divided by 2 is what? 8. So if we let k be 8, then it should make the remainder 0. It'll make it so that x minus 5 is a factor. So again, the trick here was just proceeding like normal, you know, and just if the coefficient is k, go with it. And then do your operation, and then, you know, just process it a little bit. Okay. So we got 8. Let's see, how do we do? I think it's working out. 8. Awesome. Okay, so the chat looks clear. I think that's good. Are there any burning questions before we go our separate ways? Going once, going twice. Let me see. Yeah, so no come available this Sunday morning at 11 a.m. Again, for the first 7 days, you can earn up to 100%. Past the due date, I think there's a 10% late penalty. If there are any burning questions, we're going to go ahead and end this session here. And have a great weekend, gentlemen. We don't meet on Fridays, so if you have a class that meets on Friday, that's probably the lab. Or you don't have a lab, but sometimes some of you guys are like logging in on Fridays and like, hey, we don't meet, so we only meet on Mondays and Wednesdays. So other than that, have a great weekend, gentlemen, and we'll meet back on Monday next week for same time, same place with the next installment. Take care. Peace. And I'm going to go ahead and make a copy of anything that you saw me writing. I'm going to go ahead and make a copy available.
Thank you, sir. Have a good day.
You as well.
Professor.
Yes.
I was getting on her to talk because I got 1, 2, 3, 4. I got 5 absences. One of them I got a 50%, and then I know I had emailed you once that I had went to the doctor. I don't know that exact date, but I tried to get a doctor note at the clinic I went to at home, but I wasn't able to. So I'm going home for Thanksgiving. So I don't know if like you want me to get one when I go home or what I got to do. But I actually was at the doctor and I was at home in St. Louis, Missouri.
Just forward it to me again, and I can mark it as an excuse for that day.
Okay, thank you. I'm about to email you that email that we have right now.
And then if you don't see it change by, let me see, 3 to 4, by like 6 o'clock this evening, just text me at my office cell phone number.
Okay, I will. Thank you.
Yeah.
And where's your office number again?
It's on the thing. It's somewhere. It's like on the syllabus, so you have to use it.
Okay, there. I'll find it.
Yeah,
but I'm gonna send an email now.
Yeah.
Okay. Thank you.
Let's see. Right here. Additional. This one. Notes. Right here. Choose this folder. Upload. Okay. And then I need to do for the next group. Constantly changing these layouts. Let's go. So phone and copy. New. Paste. 55. This is 3 p.m. Ooh, let me check it now. Because if I'm good now, I'm gonna forget. 15. Siri, set a timer for 12 minutes.
12 minutes starting now.
That's ready. Come on. Refresh that. That's good. Yes, this one. Dividing polynomials, this one. This view is like irking me. How can we make this look better? Exits. See late policy. Start. Settings. Come on. Struggling with a capital K. It's struggling. Come on. I gotta remember to do that at the end of the semester or when I create my next set. I gotta check the late penalty. If I can remember, I'll change it. 3 p.m. Okay. Okay. Checked. Okay. Broadcast. Okay. See it. Testing. Looking good. Okay. Just let that chill. For 10 minutos más. Oh well, might as well do some Easter egg content. So whenever I have 10 minutes, like downtime, I like to do a brawl in Mobile Legends. Brawls are cool because they take right over 10 minutes. So you need approximately 10 minutes to do a brawl. So just a little bit Easter egg while we wait for the next group. Let's go. So I'm live streaming this. Let's go to brawl. If I did a full match, those matches take like 30 minutes. You have to set aside 30 minutes. But these are 2-minute matches. Oh, my signal's bad. Oh, that was just so good. Oh, this is about to be bad. That's the other thing that's just like so trippy, you know, because you're working on like mobile devices. Mine is only Wi-Fi enabled. Oh, here, I'm not good with these people. Hayabusa, I'm not good with him. I'm gonna switch out here. Oh, this is my girl. I don't know about this mode. Let me see if there are any other options. I'm not finding any of these. Let me see if anybody wants them. Builder. Oh, this is bad. Yeah, I'm not good with that hero. All right, this is it. This. Okay. Let's ride. I'm gonna play her like a tank. But during a regular match, man, she's fine. And it just depends on like you just need one brave, like durable teammate. Oh man, she'll get him in there. Like somebody that's trying to be in their face. Melissa, I'll try to beat her tank. We got 2 mages, a fighter. Lennox, Valentina. Yeah, she's gonna be stealing my stuff. Zaz can be annoying. We got our work cut out for us. They got these crazy mages. That's fine. I should have did that first. Prioritize.
enemy reaches the battlefield. Smash them. All troops deployed. Above the horizon rises the beautiful sun.
Here's my team. What did he have? Oh, she's. Oh my god, girl. I can't do it.
Let's make our debut in this land. Anyway,
Got me. She got me. Get her. There we go.
has been slain.
Get it. Get it.
Only the brave have the courage to
time is it?
confront the intruder.
Let's go. Let's go. Anybody else? I got 5 seconds. I will.
An enemy has been slain. Ally has been slain.
You're not gonna use it. You really not gonna use it. What to do?
An enemy has been slain.
Up.
At least you tried. Well, the ally has been slain. We better be on the road, Clint. It's a long way.
What are these guys doing? Like, they're so passive.
Don't ever look. I can do that.
It's just in the debate.
Double kill.
Hey Google, what time is it?
Double kill. Ally has been slain. Triple kill. What doesn't kill you makes you stronger. Let's make our debut in this land. I know some really cool cowboys. Can we once fight side by side? I can't get more excited to get going now. Let's make our debut in this land. Any luck you could run from this? Mega kill! Double kill! Your team destroyed the turret. What doesn't kill you makes you stronger. I know some really cool cowboys. Can we once fight side by side? Shut down. Monster kill. I can't get more excited. Let's make our debut in this land. Let's make our debut in this land. Don't ever look back.
Good game.
Double kill. Double kill. Request backup. We better be on the road, Clint. It's a long way. Killing spree. Your team destroyed the turret. At least you tried. Yet you didn't make the kill. Legendary. Double kill. Triple kill.
Good girl. Good job, girl. Serious up. Yay, we won. Yeah. So Mathilda is like,
Victory!
she's support. She's a support assassin, and you can make her real durable. And she has like a crazy healing ability. It takes a little while for it to develop, but she's good. They got me a couple of times. These guys were not playing around. All right, that was fun. Okay, let me see the time. We got a minute, 2 minutes. Hang out here for those 2 minutes. Oh, oh, all right. So we are here. Let me see. Oh yeah, we got a good amount of announcements. Let me see. I'll start here. All right, gentlemen. So, I hope everyone is doing well. Let's see. So the plan for today, we're gonna work on the corresponding homework for section 2.3. You know how this goes, right? Like if we have multiple choice questions, like an excessive amount, right? That's how we're gonna use it for attendance. If we don't have it, then you essentially will be off the hook. So you kind of have to remain vigilant in case we have any polar audience. So what I like to do, I want to do a brief rundown or like review or synopsis of the upcoming weeks, right? So today is section 2.3 homework. I want to say that exam 3, you can anticipate it to become available this upcoming Sunday morning at 11 a.m. And then for 7 days, you can earn full credit up to 100%. Past the due date, there might be a 10% late penalty, right? I think it's 10%. So that means all of next week, we're going to devote next week to exam 3. So what that means is next week on Monday, we'll do a review for exam 3. And then next week on Wednesday, that's probably going to be an attendance quiz, right? Like just an assignment quiz, anywhere from 5 to 10 questions, unlimited attempts, only available during class time. That's how I'm going to take attendance. I'll be available. My intent is to be there, be online, and I'll just be available for questions, but you have to just complete that attendance quiz. That's going to be next week during the exam. And then the week after that, so with my 2 p.m., I had a realization. So the conclusion was on that Monday, the 18th, we'll do, I think it's section 3.1, all right? And then normally we do the corresponding homework on Wednesday. I think on that 20th, on November 20th, instead of doing the corresponding homework, we'll go ahead and do the final section, which is section it should be section like 6.4, I think it is, system of equations and two variables. So that'll be on November 20th. So then from that point, we're only going to have 3 more sessions remaining, right? So that Monday, the 25th, that week of the Thanksgiving, we're going to meet on that Monday. That's going to be our first review day for the final. We're going to have a total of 3 review days. So that first review day on the 25th, we're going to focus on exam 1. So any and all sections related to exam 1. And then that Wednesday during Thanksgiving, we don't meet. I think Morehouse, I think the school closes at noon on that day, so we don't meet. We break for the Thanksgiving holiday, and then we come back December 2nd and December 4th. December 4th is the last day of class. So then on that Monday, December 2nd, you can anticipate us to focus on exam 2. And then that Wednesday, December 4th, we'll focus on exam 3 along with those 2 additional sections. That Thursday, the 5th and the 6th are the reading period. And then the week of finals is that second full week of December, so December 9th through the 13th. There's a high probability that I will be hosting your final exam. Usually with College Algebra 1, it's a departmental final, but because this is remote, I think he's been just letting me create your all's final. So if I create your final, then you can anticipate it to become available on that Sunday morning, December 8th at 11:11. And it'll be due at the hard deadline, which is that Friday, December 13th at 11:59 p.m. So on that day, not only is the final exam going to be due, but all of our assignments. That's the hard deadline for everything. So I think we had late penalties automatically built into everything else. That Friday, December 13th should be the hard deadline for everything. So leading up to the final, you definitely want to try to get as many of your assignments in Pearson in order as possible. If you're going back to work on old assignments, I would encourage you to prioritize your exams first because that's where you're going to get the most bang for your buck. And then prioritize the homework last because that's going to be a lot of work for minimal points. And then also I think you all have the lab. So whatever grade each Dr. Lamar gives me for each of you, I'm going to scale that so that it counts as 10% of your overall grade. So what we do together counts as 90%. And then what you work on with Dr. Lamar counts for 10%. And then I'm open to an extra credit opportunity in the form of your overall My Math Lab score, where I'll take your overall My Math Lab score and scale it so that it counts for 10% of your overall grade. I'll do that if I can, provided it doesn't skew the grades too heavily. All right. Okay. As usual, if you have questions, feel free to either unmute yourself or type in the chat to get my attention. I'm monitoring the chat and the Q&A, and we'll be sure to get your answer. I was about to say, be sure to get your answers questioned, or scratch that, flip it around, get your questions answered. All right. Okay, I can't think of anything else. So that's the meat and potatoes, and we'll probably be doing this kind of synopsis from here on out. But yeah, we only have really it's only 2 more sections of new content. Then the rest is like review. Okay. So for today, we're going to start off here. We'll go for a random number. Let's do one more. Okay. Let's start off with question 30. This isn't too terribly bad, I guess. It's quite a bit. I'm not feeling this. It's just irking me. So I'm just trying to decide how I want to do this layout. It's a little bit excessive, but I think I'll give it a go. I'm gonna do something kind of like that. Right there looks decent. Because I want to include your question ID. So that when you're referencing, you know where it's coming from. I just don't like the way it looks. I want to duplicate this. So this one, I'll crop it. Like that. Can I merge these? Right. So I guess enough like that. Okay, let me see. Still not really feeling that. Now, let me see. I think, yeah. So Pearson recently like updated their layout. I mean, I guess you can see that. I guess we'll work with that. It's a little bit kind of weird. Let me get rid of this. Come on. And then my device is like even extra slow. I'm just gonna grab this. Is this a factor? I'll grab this one. Can I just copy and delete? Let me see. Copy. Let me try copy and delete. Hopefully that works. Come on. It's here. Come on. Paste. It's like it didn't work. Yeah, because like the other format that they had, I can include my question ID so you can use it as a reference. Ooh, that's close. Okay. All right. So I'm going to get rid of this, delete, move you there. All right, that's decent. At least we have the question ID. It's a little bit extra work, but that's okay. Okay. So that way when you reference, you have it there. Okay. So use the factor theorem to check whether this polynomial is a factor of this. Find the remainder when that polynomial is divided by the linear binomial. Okay. So in order for it to be a factor, when we do synthetic division, the remainder should be 0. Uh-oh. Did I lose my image? Okay. We swap briefly. Okay. I can't do it right now because I'm in class. Okay, so in order for this linear binomial to be a factor of this polynomial, when we do synthetic division, the remainder needs to be 0, right? Okay, so let's do synthetic division. If we're dividing, if x minus 2 is the factor, then the potential 0 will go in the chair. So if x minus 2 is the factor, then the potential 0 will be 2. Okay. Then the next question is, do we need any placeholders? All right. Notice the power is the power of 3, 2, power of 1, and power of 0. So every power is accounted for, so we don't need any placeholders. So then we just take our coefficients. We got this -2, we got 7, we got a -12, and we have 13, okay? So we want to do synthetic division here. So again, the first number just comes down. On a diagonal, we multiply. Vertically, we add. Diagonal, we multiply. Vertically, we add. Diagonal, we multiply. Oh, no. It is not a factor, right? Because we got a remainder of 1. So is it a factor? No, it's not a factor. Okay. So then, is this a factor? We're going to say no. Check. Okay. What is the remainder when that polynomial is divided by x minus 2? We got a remainder of, what was it, 1? Okay. All right, I'll leave that for reference later. Generate. Let's go to question 10. Go like this. Guess I'll use this. All right. I'll probably use this. Okay. Can I rearrange it? Let me see. No. What if I do this? All right. So use synthetic division and the factor theorem to determine if x minus c is a factor. I guess I'll just do multiple screenshots. Okay. So I have that for reference. So you know where probably this looks a little bit better. All right, well. Okay. Synthetic division and the factor theorem to determine if x minus c is a factor. Okay, so again, if we're saying that x plus 1 is a factor, then the potential 0 in this case would be what? -1. So -1 will go in our chair. Do we need any placeholders? Notice the powers go 5, 4, 3, 2, 1, 0. Every power is accounted for. So we don't need any placeholders. So then we just take our coefficients. Okay. And then we do our synthetic division. The first one just comes down. Diagonal, we multiply, we add, we multiply, we add, we multiply, we add, we multiply, we add. Oh no. Oh no. Right? It looks like no. All right. Did we do it right? Let me see. 1, 1, -8, -8, -9. Oh, we missed a negative. Okay. I was like, so I don't know. My intuition was like, no, that should have worked. I'm glad we stopped and I checked my work, right? So I was missing a negative. Okay, let me highlight the missing negative. So it was this guy here. Right, there was supposed to be a negative there, right? So now we get our remainder of 0. Okay. So then is x plus 1 a factor? Now because we got our remainder of 0, we would say yes, it is a factor. Final check. Okay, I think we got a little bit of rhythm going now. Generate. We can go to question 21. 4, 3, 2, right there. First, I'm gonna just get a screenshot of this to use. Honestly, that's not too terribly bad. Maybe I'll put that there. And I'll just use that. That's fine. Can I just get rid of that? Okay, I'll just use this. Find only the rational zeros of this function. Okay. So let me get a copy again. So we'll take it from like here to about right there. Like so, like that. Boom. Okay. Take that and pop it right here. Boom. All right, I can work with this. All right. So find only the rational zero. So this sounds like an application of the rational zero test, which is our P over our Q. Okay. Where the factors of P come from the constant term. So the constant term in this case is the 22. So we want to do all factors of 22. So plus or minus 1 and 22, plus or minus 2 and 11, and I think that's it. right. Okay. And then the factors of Q coming from our leading coefficient. Well, we got lucky in this case because our leading coefficient is a 1. So then, no need to write it. So that means we have all the combinations automatically. I find only the rational zeros. Okay. So I'm going to kind of use a shortcut. My shortcut being, I'm just going to look at the graph. All right. Let me see. So I break out my trusty dusty rusty. Let's move you over here. Clear. Y equals clear. Okay. So now I'm going to put in x to the power of 4 plus x to the power of 3 minus 13x squared minus 11x plus 22. Okay. And so I'm just going to look at the graph and see and look at my x-intercepts. Okay, it looks like 1 is one of our zeros, right? So let's confirm or deny whether 1 is one of our actual zeros. When I look at the graph, it looks like it crosses the x-axis at 1. So I'm gonna start with 1, right? Instead of doing guessing and check to try to find that first zero, I just looked at the graph. Okay. So now we want to see, is 1 one of our zeros, right? Do we need any placeholders? If we look at the powers, it goes 4, 3, 2, 1, 0. So every power is accounted for. So then we just take our coefficients. 1, 1, negative 13, negative 11, and then 22. Okay. So let's see if we get 0. Vertically, so the first one just comes down. We multiply, we add, we multiply, we add, we multiply, we add, whoops, we multiply, and indeed, we get a remainder of 0, okay? So we found one of the zeros. If we started with a degree 4, at this stage, now we're at a degree 3. Okay, so then we want to try to factor this guy. So since it's a degree 4 polynomial, we have at most 4 zeros. Now, if we look at the graph again, we said 1, we shouldn't, that's probably not a rational. Maybe it looks like negative 2 might be one of them. So let's try negative 2, right? Again, we could do guess and check. I'm just using the graph because we have it just for the sake of time, okay? So let's see if negative 2 is another 0. So if negative 2 is our 0, now we're going to take the depressed equation. Matter of fact, let me just put it here. So we're just going to use those coefficients there. Hopefully that's not too jumbled. Nah, let me not do this because I feel like it's a little bit jumbled. So the coefficients are 1, 2, negative 11, and negative 22, okay? So again, that first number just comes down. Diagonal, we multiply. Vertically, we add. We multiply, we add. We multiply, and God is good, all right? So we confirmed that 1 and negative 2 are zeros. If the above equation was power 3, this one is now, this depressed equation is now power 2, okay? So let's write out what we have so far. So right now we're saying that f of x equals, the first 0 we got was 1, so we're going to say x minus 1 times x plus 2, and the final quadratic that we have right now is this x squared minus 11, okay? Now the question asks us to find only the rational zeros. So I think from that quadratic, if we add 11 and take the square root, we get irrational zeros. So the only rational zeros it looks like we have are 1 and negative 2. And I'll just highlight them in green. So 1 and negative 2. So these are our only rational zeros here. Okay. So we got 1 and negative 2. Okay. 1 and negative 2. I feel like there should be questions. I hate to suppress this. Let's see. What if I do this? That doesn't seem help. It'll be there. I'm not gonna worry about it. The Q&A looks good. Chat looks good. Okay, let's keep going. Generate. Let's go to question 17. Okay, similar deal. So find all rational zeros of this polynomial function. I'm going to move that down. I'll move that up as far as I can. And we'll work with that. I think we can work this similar to the last one. I see I'm starting to catch my rhythm and flow, my hustle and flow. Hey, yo, man. Man, I don't know if I just be sleepy. I just be like, my mind does not be here. I be thinking about everything else. All right. Here. Come on, all right, quick. Ooh, just made it. Okay. Let's go like this. So find all rational zeros. Okay, so again, when we do that P over Q, those are not the actual zeros. That's just the list of possible rational zeros. So our actual zeros are somewhere in that list. So we have to go beyond the list to find the actual zeros, right? Okay, so we're gonna do the rational zero test again, okay? We're gonna do our P over our Q. I don't even know what I'm writing there, right? The factors of P come from our constant term. So that's a 21, which is what, 3 and 7. So then that's going to be plus or minus 1, plus or minus 3, plus or minus 7, and plus or minus 21. Okay. The Q comes from our leading coefficient, which is just a 1 in this case. So we got lucky. Our list is already generated. I think I'm going to look at the graph to just, for the sake of time, instead of guessing and check. Let's see if I can still do this. So H, X, I think X is here. Let me see, to the power of 3 plus it's here, 3x squared. Where is the squared? I. Okay. X to the power of 3 plus 3x squared minus W, withdraw. 25x plus 21. Okay. So we were just looking at the graph. 1, it looks like 1, 3, and negative 7. 1, 3, and negative 7. Okay, let's start off with 1. The first one is confirm it or not whether 1 is a 0. So we'll put 1 in the chair. Do we need any placeholders? The powers go 3, 2, 1, 0. We don't need any placeholders. So let's take the coefficients. 1, 3, negative 25, and 21. Okay. The 1 comes down. Diagonal 1 times 1 is 1. 4. 4, negative 21, negative 21, and we indeed get our remainder of 0, right? So 1 is indeed a 0. We started with a degree 3. At this stage, now we're at a degree 2 for this depressed equation, okay? And then I think we can just factor that, right? So if 1 is our 0, that first factor takes on the form x minus 1. And then we want to factor this. We got this x squared plus 4x minus 21, okay? We're going to set it equal to 0. So then the question is, our goal, we're trying to factor this trinomial into some form like this. The x minus 1 just comes down. We have x and x, opposite signs, so one's positive and one's negative. 7 and 3. 7 and 3. 7 times negative 3 is negative 21. 7 plus negative 3 is a positive 4. So this should be the completely factored form of the original. Okay. So then the zeros, they're negative 7, 1, and 3. Which is what I think we got from the graph, but you still wanted to back it up. Because sometimes the graph will give you fractions or irrational numbers, and it can be kind of challenging. Again, I just kind of use the graph to quickly find like a few, whatever zeros that are simple to find. and then we can use a depressed equation to simplify our overall equation. You know, -7, 1, and 3. This one. Come on. That's fine. -7, comma 1, comma 3. Okay. Generate. Let's look at question 10. Okay, so since we did 10, we'll go ahead and do 11. Okay, this is an interesting one. Find k such that this has a factor of x minus 2. So let me get a screenshot. If I could rearrange this somehow. But anyway, at least I get my question ID. So that's the main thing. I want you all to be able to use that if needed. You know where in the book is coming from. I know it's a little bit smaller, but has what I need. Okay. So we're gonna drop that. Come on, quick. Hold on, I gotta. Okay. Oh, what are you doing? Right there. All right, I think we're Gucci. All right. So let's expand this. Work with that. So again, we're asked to find a k such that this polynomial has a factor of x minus 2. Okay, so let me see. I know it's a little bit small for you all. Okay, so if we want x minus 2 to be a factor, that means that when we do synthetic division, the remainder should be 0. Okay, so let's just follow that train of thought. In order for x minus 2 to be a factor, that means that the potential 0 is going to be a positive 2. So we're going to put 2 in the chair. Okay. Then next, if we're doing synthetic division, the next question we ask ourselves is, do we need a placeholder? The powers go 3, 2, 1, 0, so we don't need a placeholder. Okay. So then we just take the coefficients. So then we're going to take a 1. The next coefficient is negative k, just go with it. The next coefficient is k, again, just go with it. And then the final coefficient is 10. Okay. So now we're just going to do synthetic division. Again, just go with it. Again, that first number just comes down. On the diagonal, we multiply. Vertically, we add. So that'll give us a 2 minus k. Diagonal, we multiply. That's going to give us 4 minus 2k. Vertically, we add. That's going to give us 4 minus k. We combine like terms. 1 plus negative 2 is negative 1. Diagonal, we multiply. That's going to give us 8 minus 2k. Vertically, we add. So we combine like terms. We're going to get a remainder of 18 minus 2k. All right. So then from here again, if we want x minus 2 to be a factor, we need the remainder to equal 0. So long story short, we need this 18 minus 2k. We need that to equal 0. Okay. So then we add 2k to both sides. We'll get 2k equals 18. Divide both sides by 2, and k equals 9. Okay, so, testing or challenging your understanding of the concept here, right? All right, let's see, how do we do? We got a result of 9 there. All right, what's the time? We got a solid 15 minutes. So let's make the most of it. Generate. We just did 11. We'll go ahead and do the next one. Sure, why not? We'll do another one. We'll do it again. Like this. This is a little bit smoother. Again, I don't really like the layout, but I can get it to work for a few of these. More space. I think the space is good. Okay. Right. Yeah, just a little bit. Okay. So same kind of deal. We want x minus 5 to be a factor. So that means that 5 should go in the chair. Then we need a placeholder, 3, 2, 1, 0. So we don't need a placeholder. So then our coefficients, we have a 1, negative k, and then 55. Okay. So if we do synthetic division, again, that first number just comes down. Diagonal we multiply, vertically we add. Diagonal we multiply, that's a 25 minus 5k. Vertically we add, that's going to be 25 minus 4k. We multiply, that's going to be 125 minus 20k. And then for our remainder, we're going to add, what is that, 70? Let me see. No, that's not 70. That's a 30, 80, 180, right? 180 minus 20k. Okay. So in order for x minus 5 to be a factor, we need the remainder to equal 0. I'm going to write like this. So 0 equals 180 plus 20k. Oh, not plus. My mind is not here. Minus 20k. So now we solve, add 20 to both sides, or the 20k. Divide both sides by 20. It looks like k equals 9 again. Okay, so let's see if 9 works. Nine. Enter. Okay, what's the time? We got a solid 10 minutes. Generate 16. Let's look at question 16. Okay, list the potential rational zeros of this polynomial function. Do not attempt to find the zeros. Okay, so if we're going to do, I know this is multiple choice, and I think I do want to give you all an opportunity. I don't think I'm necessarily going to use this for attendance just yet, but I do want to get you all. I might. It just depends. So do your best to get this one correct. Just do your best. So, trying to think how I'm gonna do it. I really just want to. Let's go to polls or quizzes. I'll leave it to 1 for now. It's fine. I want that one. Yeah, this is fine. So, okay. So there's a poll that's active, right? List the potential rational zeros. I want to give you some time. So about a minute or so. I know it's kind of jumping. So just take a moment. Oh, I'm gonna go like this. And I guess I have to zoom out. Yeah, I'm gonna have to zoom out. Let's go ahead. One more time. Okay. All right. So we got one. Let's take a full minute. So when the timer gets to 2, we got a minute and 15 seconds left. So when it gets to 2 minutes, I just want you to take some time to think about this. I'll be back in a minute. 30 seconds. Uh-oh. I was like, do I need to make this attendance? You guys there? 5, 4. All right. Can we get any others? Going once, going twice. All right. Oh, again, it's depending on my mood. You had to guess. All right, I'm gonna close this out. Okay. So the poll is closed. Okay. Let's see. Possible rational zero. So that's our P over our Q. Our P will come from, let me get rid of this. Our P will come from, and let me minimize this some. That's better. Will come from the constant term. So it's, the only factors there are 1. Our Q will come from the factors of our leading coefficient. In this case, would be 5. So it will be all the combinations of 1 over 1 and 5, which should be C. All right, so I'm going to go with C. So I think C was correct. I think everybody that answered got that correct. So, you know, we're going to kind of leave it for now. We got time for some more. 13. Let's see, question 13. And we did 13. Okay, let's try 14. This more than likely, use the factor theorem to decide whether this, okay. I could do multiple choice here, but I probably won't. I want to zoom in some more. Trying to get it back to whatever setting I had before. So this will probably be our last one for the day. This is question 14. That's decent. Okay, use a factor to decide whether x plus 4 is a factor of this. Let me get a copy. All right. Okay. Good. Should I go faster or no? Oh no. Okay, like that. Come on. Oh, use the image after a certain amount of time, then I'll lose the image. Then I have to redo it. That's how we work. So it's like very sometimes it works. Okay. So is x plus 4 a factor of this polynomial? Okay. So in order for x plus 4 to be a factor, that means the potential 0 would be negative 4, right? So we need to put negative 4 in the chair. Do we need any placeholders? The powers go 4, 3, 2, 1, 0, so we don't need any placeholders. We take our coefficients, 4, 9, negative 24, 17, and 4. Okay. So in order for it to be a factor, the remainder needs to be 0. Okay. On the diagonal, we multiply. So that's a negative 16. Vertically, we add. That should be a negative 7. Then a positive 28, a positive 4, negative 16, positive 1, negative 4, and indeed, we get our 0. It's like magic. It's just like, I don't know. It's so like gratifying. I don't know. It's so weird. Okay. So we did get a remainder of 0. So then we can say, yes, x plus 4 is a factor of that polynomial. Right? If we were to guess, you know, we have a 50-50 chance of getting it correct, but chance favors the prepared mind. We drastically boost the odds of success in our favor when we are prepared, right? Okay, what's the time? Let me see what the next one is, and I'm gonna gauge it if I feel like it's quick. Number 1 should definitely be quick. Let's see. Use synthetic division to find the quotient and the remainder when the first column is divided by the second. All right, well, this will be the last one. We'll go ahead and do it. It's not too bad. So this will be it. Take that. Here. Let's go out right there. That's decent. Okay. So if we're going to do synthetic division, again, if the factor is x minus 1, then the potential 0 is going to be a 1. Do we need any placeholders? 5, 4, 3, 2, 1, 0. We don't need any placeholders, so we take the coefficient. 1, 2, -7, 1, -1, and -2. Okay. In the first, let me check it one more time. 1, 2, -7, 1, -1, -2. Okay. So the first number just comes down. Diagonal, we multiply, we add, we multiply, we add, we multiply, we add, we multiply, we add. Oh, looks like it's a no. Oh, they want the quotient and remainder. We multiply, and we get a remainder of -6. Okay. Okay. 13, 434. 13, 434. 13, 434. 6. 13, 434. 6. Come on. 13, 434. Okay. We started, let me minimize this. And there was a 6 over here. Was it 6 or was it -6? Check real quick. It was -6. Come on. Okay, we got that one. Okay. I know that these guys are negative. Okay. So let's see. We started at degree 5. So now at the end, we're going to be degree 4. So it's going to be x to the power of 4 plus 3x squared, nope, cubed, minus 4x squared, nope, 4x squared minus 3x minus 4. Okay, I think this is good. 13, 434, -6. Okay. All right. Are there any burning questions before we go our separate ways? Going once, going twice. Forever hold your peace. Let me do a quick recap. So I'll make a copy of these notes available. Let me see. Yeah, so you can anticipate exam 3 to become available this upcoming Sunday. So what that so it should become available this Sunday morning at 11 a.m. Again, for the first 7 days, you can earn up to 100%. Past the due date, the highest you can earn on any question submitted late is like a 90%. So what that means is next week on Monday, we'll probably review for the exam. If you do your exam early and you have questions, you can ask questions about the exam during class. But if you feel confident, then you're good. Once you complete your exam, then just be sure to get your attendance credit. Monday, we'll do a review session, okay? And then Wednesday, more than likely, it'll be an attendance quiz, and I'll probably stay on the line. Like I'll do a quiz. It's like either 5 to 10 questions. You can only access it during class on Wednesday. That's how you get your attendance that day. And I'll just be on the call, just using it as unofficial office hours. I'll just be here. And we kind of talked about the tentative schedule closing out, okay? So if there aren't any other burning questions, we're going to go ahead and end the session here. From one beautiful mind to another, have a great weekend, gentlemen, and we'll meet back on Monday, same time, same place, for the next installment. Take care and peace. Hey.
Everybody knows that I'm breaking down. Everybody knows I ain't faking now. Everybody knows my heart's faking now. Yeah, she hates me now. I'm in mistakes for now. I don't ever wanna be alone. I don't really ever feel at home. On my own, in the zone. That's the only way I know. Feeling out, about to blow back up. Never never let the doubt creep in. Gotta pop a cup to more best friend. I don't think I'll ever let you in. Easier to break it off best friends. I don't really understand myself. I don't really understand me. I don't wanna be the dog on the show. Couldn't